All right, I started recording. Right here is the 5 core lessons. When you multiply exponents, you add. When you divide exponents, you subtract. When you raise exponent, you multiply. Anything to the 0 exponent is the number 1. And negative exponents go on the bottom. Those are the 5 core rules. What's tricky about the test is not necessarily when you do one rule at a time, but the tricky part is when we combine the rules in like multiple questions. So I made 10 questions to show that, which is really representative of your test. I looked at your test and I just changed a couple of numbers around. Yeah. It should be, yes. Nice catch. So it should be positive when it's on the bottom. Thank you. All right. Schnare, sit down, man. You're going to ruin it for everybody. Trust me. All right. Let's talk about one question at a time, okay? Again, these are literally based off your test questions, okay? So I looked at your test and just made up questions off that. So let's look at this first one. This is going to be x to the third times x to the fifth. Remember, if you don't see something, it's x to the 1. You just add these up to be x to the 10. That's your final answer. Number 2, I have multiplications on top of divisions. It's okay. What I would first do is just multiply the tops together, which means you add them. So 4 plus 7, x to 11, and then 5 plus 1, x6. Now I have this, I divide. 11 minus 6, x5. Again, the trick or the difficulty is not the 5 rules. The difficulty is when I combine the rules.
And you don't divide area.
You subtract the exponents, yes. Normal numbers you treat normally. That's the whole test. Next one. I'm going to put this over 1. When I put it over 1, now I can make it one fraction. So x to the third over x to the 7. Because you can multiply sideways or straight through. Don't do that. I know. Don't do that. It's so weird. What's up? The ones? It's 1 times, 1 doesn't change anything. So 1 times whatever doesn't change anything, okay? So x to the third times, or divided by x to the 7 is x to the negative 4. X to the negative 4. Shh. Guys. Because it's x to the negative 4, I'm going to move that to the bottom. So it's 1 over x to the 4.
Where did the 6 come from?
The 6.
Oh, that's not a 6, that's an error.
Okay. My bad, yeah. Next one, number 4. It's just a mix operation. So 2. I'm not going to get mad on the video. So I'll just wait. Yeah, what's up?
The 1 in number 3, the 1 always has to be on top, like 1 over x and then the...
If there's nothing left on top. A couple of them you'll see there's some things left on top.
Oh, so there's nothing on top. Like...
If there's nothing on top, you put a 1 as a placeholder. I got it on the next page, don't sweat it. All right. Yeah, what's up? No, not right now. I'll let you after the video. So this one, 2 times 4 is 8. Notice how they're normal numbers. So I'm not adding them. I'm just straight up multiplying them. But the x's get together. 7 plus 2 will be x to the 9. So remember, normal numbers still work normally. Here we have 7 divided by negative 3. So we're going to subtract, which is technically 7 minus negative 3 or 7 plus 3. So it's going to be x10. Next one. When we have an exponent on a set of parentheses, we're allowed to distribute. The only time you're not allowed to distribute if there's a plus or minus in the middle side That does not happen on this test. Yeah, sorry.
How'd you get 10? Isn't it 7 minus 1? Because 7 minus 9 is -3.
You got it, Renee?
Minus and negative is positive.
All right. So I'm going to distribute a 3 to everything here. So 3 to the third power. X, when you do power to a power, you multiply. So it's x to the 6th power. 3 times 4, y to the 12th power. 3 to the third power, though, I'm going to actually have to do, which is 3 times 3 times 3. 27, x to the 6, y to the 12. On your calculator, if you want to do a number to a power on your calculator, you're going to click this button. This button is the button above the division symbol. So 3 to the third power gives you 27. So the button above the division symbol. Again, right here, that's red right now. Hold up. No, not yet. Let's look at number 7. Negative exponents could also be distributes. There's nothing I can say about that. Negative exponents can be distributes.
Same way, right?
So I bring it here, here, and here. So it's going to be 2 to the negative 4 power. X, remember multiply,
Negative 12.
negative 12.
Positive 8.
Yeah.
Y, negative 2 times negative 4, positive 8.
And I do 2 the negative 1.
Now, anything with a negative exponent goes to the bottom, which means the 2 is going to go to the bottom, and the x is going to go to the bottom. Notice how 8 does not go on the bottom.
So 2 negative 4 x negative 12 under y8.
Y8, 2 to the positive 4 now, and x to the positive 12. When you move to the bottom, it becomes positive. Only the negative exponents do that. And then I need to do 2 to the 4th power, which is 2 times 2 times 2 times 2,
4, 8, 16.
which will be 16. So 16, x to the 12th power. Notice how everything I'm doing is one step at a time. Kind of following PEMDAS. I did parentheses. I took care of, in this case, it's technically exponents. I'm taking care of the exponents first, then do the math. Let's look at number 8. A mixed set with division and multiplication. So the top, I'm going to multiply first to make my life easy. Thank you. If you need a note, let me know. You need a note? So, you have that pencil?
I have pencils in there.
Yeah. So. All right. You're going to multiply the tops first. So 3 times 2 is 6. And then x to the 2nd, x to the 6th, x to the 8th. Because they're multiplying to each other, you're adding.
But multiplication.
Yeah, multiplication means you add. Hmm? 3 times 2? The bottom hasn't been used yet, so we're just going to write that.
Oh, that's it.
Well, now we can simplify.
So subtract
6 over 4,
3 over 2.
it's going to be 3 over 2.
and the
X
x to the
5.
5th.
And then 8 minus 3, x to the 5th.
The x and the exponent always on top, or can it be on the bottom?
Yes, it's always on the top. If you write it like this, it is also correct. That's okay.
But not on the bottom.
Definitely not on the
But
bottom.
on the bottom is not.
But either way is correct. All right. Number 9 is like,
Oh,
I would say it's like the hardest one. This would be the last question of your test.
it was very annoying.
But it's the most busy question.
Yes.
So we do one piece at a time. Sit down, man. Let it go. It's okay. No. Put it back and sit down. Okay, then sit down. I got it. I want to do it for the video, so.
Guys, shut up.
Again, I'm not going to get mad on the video. Just go to wait. Okay. For this one, we'll do 6 over 12 first. which is 1 over 2. Now I'm doing the x's. Notice here, I'm going to put all the x's or variables on top before moving anything. So it's going to be 3 minus 5, x to the negative 2. y5, y5. Wait a second. That's y to the 0. So that just completely disappears. So no y needed because it completely disappears. Negative 2 minus negative 5. That's negative 2 plus 5. So that's z to the third power. Remember, negative exponents move to the bottom, which in this case is only the x. 1 is not necessary to show, but if you put 1, you're not going to lose points. But on the top is basically only z to the third, 2x to the second.
Where's negative 2? Oh, fine. Whoever said 1 over 2. Shouldn't 2 be on the top?
This is 1 over 2, so that 2 is definitely on bottom.
Wait, I don't get this.
No, because the 1 is already there. No, because it's invisible.
Yes, 1 is invisible, so if you write the 1 or don't, you'll still get credit.
Can I just mix it up? Because why not? Can I take positive 1 from the bottom and put it
It's not that 1 is over 2. It's just that it's a half.
No, what do you mean? Like have a negative as your final answer? A negative exponent for your final answer? No, it's the rules will specifically say positive exponent.
Yeah, but like a negative exponent.
If you have a negative exponent on the bottom,
No, but
oh, what's up?
like 2 to the negative 3.
2 to the negative 3 is 1 over 8. Yeah, so you would write 1 over 8.
Right. So if there's negative exponent.
Move it to the bottom first, then exponent. Move it to the bottom first, then exponent. All right. Last example here, we also have the graphing one, so I want to go over those too. But x to the fifth, x to the third, we're going to subtract within the parentheses first. Just like normal pen does. Do what's inside the parentheses first before you start bringing things in. So 5 minus 3 is going to be x to the second to the fourth power. And now we could just multiply. So that's x to the eighth power.
That's when you multiply?
Well, exponent, yes, is when you multiply.
Wait, I was doing it wrong.
X 20.
Is that it?
Wait, it's the same answer.
No, yeah.
It's the same answer.
You could do it where you do 20 over 8, and then you, or 12 over 12, I'm sorry, and then you'll still get the same thing.
Oh, so basically there's no wrong
Not right now.
answer. That-
Not right now. No. Jacob, what's up, man? Jacob, put it away, please.
You have to look at them.
Number 10, I subtracted first, so I got x to the second, and then I multiplied, so I got x to the eighth. No. So no.
It's actually not as hard as I thought it was.
Again, I'm happy that's sentiment. Remember, it's really just 5 rules, and you're just doing them in different orders.
I get confused when you use multiple of the same rules in one problem.
I mean, that's the trick of the whole test, though, right? What? I'm not promising anything, sit down. All right. So, there's a final page. This is a thing we learned Monday, which is just there's 2 versions. It's finding the formula and finding the graph, okay? So let's first about finding the formula. There are 2 key points you need, A and B. A is always the starting point, aka when x equals 0. So in this scenario, I look at where x equals 0 and take the y value from it. So my A in this case is 48.
Wait, do I have to find the pattern?
Now the pattern,
It's times 4.
you need to find the pattern. Now, you might be able to see it's times 4, times 4, times 4. Let's say, you're on the test, you're struggling, what's happening? What you could always do is divide backwards. AKA, I could do 12 divided by 3, and I will get 4. Or if I do divide backwards, 48 divided by 12, if you don't see it, this is a guaranteed way to get it. Divided by 4. Okay? It should be consistent throughout the whole
You
thing.
can't graph 2 commas 768.
I'm not asking you to graph this, though.
Oh, you don't graph this one?
I'm giving you the table, you just give me the formula. So it's 4 times x, or to the x power, I'm sorry, to the x power. So the two things I look for in this grade, or this question, is the a value and the b value. That's the only thing that ever changed in this question, okay? All right. Last one. This is, yeah, what's up, Jackson? Yes. So, graphing over here, these are the steps that I gave you on Monday. I'm not going to make you copy it down, but you could look at it again when you watch the video. In this situation, you always first start off by making the table. Then you fill the X's. I always suggest 0, 1, 2. I'm basing the question that you're plugging in 0, 1, 2. But you could technically use any numbers, but 0, 1, 2 tends to be the easiest. Then you're going to use X's to find Y's. Guys, the horseplay with the pencils, staples, paper, we got to stop that. We got to stop that.
Can I get a drink of water?
All right, Jackson, sit down for me. All right, so I take the 0 and plug it into the equation. So y equals -2 times 3 to the 0 power. Remember, from the 0 power is always 1. So -2 times 1, this is -2. Okay? Yoni, just give back the phone and then Renee put the phone in the sleeve. Renee, put this phone in the sleeve. Hold up. Yeah, no, I'm waiting.
Texting my mom about a math tutor, please give me
Don't worry, you're just holding up everybody else. It's okay. Yes.
Take your time.
actually discussed it now.
I know. Next one. We're going to plug in 1. So same thing. Y equals -2 times 3 to the 1 power. Well, 3 to the 1 power is just 3. So -2 times 3, -6. And then we'll do the last one. Y equals -2 times 3 to the 2nd power. Remember, 3 to the 2nd power is 3 times 3.
So it's 18.
So -2 times 9.
-18.
So -18.
That's what I said.
Yes.
Every time something is like power of 0.
Yes.
Yeah.
Even if it's a whole group of things, there's always 1.
Wait, so and it's so good, then you have to graph it?
So then you'll have a graph on your table, or you'll have a graph on your paper.
Will we have numbers like -18 and we can't graph?
Now, if you do 0, 1, 2, they will fit.
So also, it won't be -18. Or it will.
In this case,
Like it will be a number.
it'll be a number that will fit if you do 0, 1, 2. Yeah.
On every equation, like on every one of our classes,
That's what I suggest. Technically, you use any numbers.
but will they fit every time?
Yes. I made sure. And there's like 2 graphs, so there's not that many difference. All right. So I'm putting my points here. One part that's important is to note this is a curve, not a graph, or not a straight line. So it should represent a curve correctly, which means I should be able to visualize that it's curving up here, and there's that straight line over here, like the tail of the shape, okay? It should be straight. It should not look like something like this. I should not see something like this. This is completely wrong. Once again, should be some kind of curve like this.
So Mr. Toe, it's always
Always a curve in this section, always a curve. Okay?
100%.
Okay.